next session, it's really hard to pick a favorite, but I always love these lightning talks. They're really going to highlight the breadth of female athlete research happening across Stanford and beyond. So in this session, next slide, we're going to have some lightning talks. Oh, I think I got to do it, huh? There we go. Okay, so we're going to have lightning talks from some of our scientific poster presenters. So we've challenged them to give a 2-minute introduction to motivate you to come and chat with them more at the poster session. We're also going to have translational talks from 4 experts in human performance. The talks will discuss unmet needs, opportunities for collaboration, success stories, and we also, they'll be hanging out up front during lunch so you can come talk to them more as well. So we'll have odd posters at lunch, even posters at happy hour, and we have our lightning and translational talks. We are going to do a kind of sprint relay here. Our baton is the clicker that I will pass. I think it's a 12-person relay if I counted correctly. I'll ask the speakers to introduce themselves and introduce their work. And first up, we have Anita Reddy, passing the baton.
Okay. All right, let's see. Oh. Hi, everyone. Thank you all for being here today. My name is Anita, and I'm a postdoc in Justin Sonnenberg's lab. And I'm really interested in understanding the relationship between exercise and the microbiome. And so our microbiomes consist of trillions of bacteria that reside within our gut and can actually really impact human health. And the relationship between exercise and the microbiome I like to think of it as a bidirectionally impactful one, with each component really influencing the other. And it can be broadly categorized into 3 ways. So you have exercise positively impacting the microbiome, improving the diversity of the bacteria that comprise the microbiome as well as its function. Conversely, you also have the microbiome influencing athletic performance, where several researchers have seen that the presence or absence of certain bacteria within our microbiomes can actually either enhance or blunt aerobic capacity. And then lastly, you also have the microbiome actually mediating certain adaptations to exercise. So our lab and others have shown, our preliminary data, I should say, from our lab as well as several other labs have shown that following exercise, individuals typically experience improved glucose sensitivity, and this appears to be largely mediated through the microbiome. And so while these examples are really well categorized of exercise and the microbiome really influencing one another, it's still poorly understood what are the signaling events that are mediating these processes. So I'm really interested in trying to identify bacterially derived metabolites that are produced during exercise and then understand their role in the adaptation to exercise. And I don't really have time to get into the details during this talk, but if you guys are interested in learning more, please come find me and we can chat. Thank you.
Good morning. I'm Cynthia Kapphahn. I'm medical director for the Stanford Medicine Children's Health Eating Disorder Program, inpatient program. I'm also clinical professor and adolescent medicine physician. As we've learned, inadequate food intake and overexercise can lead to energy deficit and medical complications that can include low heart rate, low blood pressure, poor bone mass, and menstrual abnormalities, and also increased risk for sports injuries. Stanford Medicine Children's Health Eating Disorder Program has been treating female athletes with energy imbalance for many years, including individuals that have intentionally restricted as well as those who simply underestimated the energy needs of their sport. We have an inpatient medical stabilization program that provides medical, psychiatric, and nutrition support, an outpatient eating disorder clinic, and also an eating disorder specialty clinic at Vaden Student Health for Stanford University individuals. All of these programs treat youth and up through age 25. We all have a role in raising awareness of the medical complications of inadequate intake in female athletes. This includes encouraging routine screening and monitoring of vital signs when trans and mental status by all sports medicine and performance athletes, professionals, as well as evaluating and treating female athletes with amenorrhea with nutrition, not with hormones. There's research gaps we'd love to help with on how to encourage female athletes from recovering from medical instability from overexercise. This includes how and when to safely reintroduce exercise and also what an acceptable minimal heart rate is. Please come see me at poster 26 to talk more about this and energy balance in athletes with eating disorders. Thank you.
Hello, everyone. I'm Rachel, and I come from the Kogan Lab, and today I'll be talking about a very important topic, bone stress injuries. Bone stress injuries are extremely common, especially among athletes and runners, and they disproportionately affect women. And as of right now, there are no objective measures for assessing the progression and return to play for bone stress injuries, and that's where my purpose comes in. And that starts with one of the many reasons why MRI is very cool. As you can see in the middle of my slide, noted by the pink line, there's swelling on the bone, which comes from the bone stress injury, and that's step one. Furthermore, you can use quantitative MRI to come up with a scale and help you get your edema fraction. Edema fraction is essentially how much swelling is present there, which I've highlighted in blue. And as you can see from baseline and onwards, the blue gets smaller, edema fraction decreases, the swelling lessens, and we are one step closer, I hope, to finding objective measures for bone stress injuries. If you'd like to talk about this further, please come find me at my poster. Number 28, not 17.
Hi, this is Jade. I am from a postdoc from Dr. Constantine's lab in the Department of Orthopedic Surgery. Today, our project focuses on knee health after ACL reconstruction surgery. So you've heard that females have a higher risk of ACL injury, and females also have a higher likelihood of developing osteoarthritis. And previously, in our study, we found that at 2 years post-ACL reconstruction, 64% of our participants show that they had not reached a perceived acceptable symptom state. And so that led us to ask this question. So at about 2 years after ACL reconstruction, what is knee health like in females compared to males? So we look at this using 3 connected measures about knee health. One is that how patients say their knees feel and function. And number 2 is the biomechanics, like how the knee actually function. And for general knee health, we could get some of these biomechanical markers from just walking. Number 3 is what Rachel talked about, MRI, so 3D bone shape from MRI data, because certain shapes tell us the risk of like future problems like arthritis. And so what we found is that in females, when knee function look stronger and patients were reporting fewer symptoms, their bone shape actually look healthier, less osteoarthritis-like. And for males, on the opposite, we saw that with better knee function, we actually saw more OA-like bone shape. So that is a finding that surprised us and generated a lot of questions thinking about like recovery patterns in females versus males. How do biomechanics play a role? Physical activity level? What about the actual return to sport timeline? So with all that said, my take-home message for you is simple. I think we need to better understand recovery after ACL reconstruction surgery. And I also hope that I left you thinking more about what are something that we could do more to support recovery as well as lifelong knee health.
Hello, my name is Tyler Friedrich, and I'm an Associate's Athletic Director for Applied Performance here at Stanford in our athletics department. And my job is to oversee 4 of our student athlete service areas. So that's sports performance, sports science, sports nutrition, and our equipment teams. And with those groups, we work in conjunction with our medical teams to coordinate the care and performance models for our student athletes. I also am the sports performance coach for our women's volleyball team, 9-time national champions, and not all with me. And I've been working with female student athletes, training female student athletes for the entirety of my career. So currently we're at a time where equipment that was once seen in the laboratory is now commercially available and used in everyday training. And with these tools becoming more available, the insights and information on our student athletes is greater now than it ever has been. How they move, where they're deficient, the physical demands of the sport, all of this is collected and analyzed on a daily basis. But with that comes extremely large data sets to comb through, analyze, share, and whatnot. And so the question becomes, like, how do we make this information impactful for our key stakeholders? And what we do is we try to take this information and reimagine or just reconstruct it in a way that really is impactful for our key stakeholders. And so that could be a table with colors that show positive or negative change within the data set. It could be a more granular table that shows breakdowns of session data or drill by drill, player by player, or even a dramatic effect, like just charts and graphs that show more of a generalized summary in a visually appealing way. The key is we want to emphasize sharing this data both effectively and efficiently with our key stakeholders. And when we do this, we actually empower a multidisciplinary team to leverage their expertise in their areas more specifically. And really, as we continue to build, be more efficient with sharing our information, we can raise our standard of care for our student athletes. Thank you very much. I'll be around, or if not, you can email me here. Thank you.
Hi everyone, I'm Sela. I'm the lead researcher of the Female Athlete Program at UC San Diego. So just for a little context, I have a pretty unique role here where I'm a researcher fully embedded within athletics. So I'm working as a sports scientist and I'm spending time on the floor in the weight room with the athletes every day. It's my dream job. But I'm here to integrate female athlete health initiatives into our existing workflows. So when I was first hired, I was fresh off my master's and I was ready to hit the ground running. I had plenty of ideas for research, but just by being in and around these athletes and chatting with them, I came to find a striking knowledge gap around menstrual health paired with widespread misinformation coming from social media, right? So I realized this was the need. So I needed to level the playing field of foundational knowledge before moving forward. So I started small with a 15-minute in-person presentation just on the basics of the menstrual cycle that I delivered to our off-season teams at the time. I actually utilized an educational handout that came out of Stanford, shout out. And then I began each one of my sessions with a 6-question, how much do you think you know, quiz that they all went in very confident, right? But the average score was a 35%, right? And this was given to over 100 athletes. So this was a striking number to me. Despite that, these education sessions were actually incredibly well received. I went on to create 2 more, each one building on the last. And with that, we saw more engagement, more athletes coming forward, asking questions, wanting to talk about their specific experiences. And we realized we needed more structure to support this increase in demand. So we created the Female Athlete Resource Hub, which is a centralized triage system to make sure that athletes are plugged into the appropriate resources based off of their needs. But big picture here, this is the science in service, right? And this is laying the foundation to athlete-centered research. So as we continue to refine and expand this model, I would love to hear from those of you doing similar work, because I know there's plenty of you, and I extend an invitation to collaborate. Thank you.
Hi, everyone. Thank you so much for being here today. I'm really excited to tell you about some of my research. My name is Lara, and I'm a bioengineering PhD candidate at Stanford in the Zeitzer Circadian Research Lab. And most of my research focuses on how timing and biological rhythms influence performance. Today, I want to share with you some of our research, specifically examining what dimensions of performance are most impacted by timing, so daytime versus nighttime performance in young, healthy women. We recruited 48 young, healthy women who had regular menstrual cycles and who were not on hormonal birth control to participate in 2 in-laboratory assessments of neuromuscular performance. One of these assessments happened at the hypothesized peak of performance around 8 hours after habitual wake time, roughly in the late afternoon. And then we also had a second in-laboratory assessment that occurred at the hypothesized low point of performance around 3 hours before habitual wake time. So we are regularly in the lab between like 2 and like 4 a.m. for about 9 months. Through this research, we sought to, tease apart which dimensions of performance were most impacted. So the first thing that we wanted to test out was muscle strength. We looked at muscle strength at the knee location with a humagnorum dynamometer. And interestingly, we found that the hamstrings were weaker during the nighttime, but not the quads, which we found to be pretty interesting and maybe ties back to some of the neuromuscular performance and mental model work previously discussed. We also found that when we examined more functional tasks, such as a drop jump, there was a decrease in jump height of about 7.5%, which is pretty substantial in the context of performance. So overall, we find that some, but not all, dimensions of performance are impacted by timing and the menstrual cycle. And this has important implications for teams that may be traveling, such as the Stanford teams that are going back and forth between the East and West Coast, timing for some of your practices, and then also managing expectations around the menstrual cycle. And if you have any questions on any of this or want to hear more about some of the other tasks that we looked at or the implications across the menstrual cycle, please come visit me at Poster 9.
Hi, my name is Olivia Leupold, and I'm a research assistant at the Hospital for Special Surgery, and I'm going to be talking about the social media trend of cycle syncing. Cycle syncing refers to a method of tailoring your exercise to the different phases of the menstrual cycle, and the term was first coined in 2014 and has since gained popularity across social media. And with the rise of young people, and in particular young women, either intentionally or unintentionally obtaining health information through social media, we thought it was important to better understand what information was being shared. So in order to do that, we analyzed 160 different TikTok videos. They all scored poorly on 2 different instruments used to assess scientific accuracy as well as instructional value. We also looked at the content. 98% of the videos were pro cycle syncing, so essentially all of them. And many made really grand claims about its ability to increase energy, optimize athletic performance, and even potentially prevent injury. And so we thought that was important to highlight because the current research presents a much more nuanced picture than would be currently portrayed through the overwhelmingly positive attitude on social media. We also thought it was important to highlight that 81% of the videos were posted by users that were selling or promoting the sale of products through their profiles, many to do with cycle syncing. So if you would like to come chat more about this online trend and talk about maybe some red flags or tips when obtaining health information online, like alternative incentives, I'll be at Poster 7. Hi, everybody. Thank you so much for having me today. My name is Rachel Logue. I am a postdoc fellow at the University of Michigan, and I work with Dr. Sandra Hunter. Today, I'm going to bring us to the other end of the age spectrum. I'm going to talk about the aging female. And there are quite literally tens of thousands of masters athletes who are females out there. And we know that females decline in performance and muscular strength more rapidly than men do after age 55 or so. And this really links directly with when females go through the menopause transition and lose a massive amount of estradiol, which is one of the primary estrogens, during this time. So this got our lab thinking, what happens when females are taking hormone replacement therapy? Can this offset any of these declines that they are experiencing? And so we looked at a nationally representative sample of over 1,000 females, and we looked at their muscle strength, and we found that those who had reported any history of hormone replacement therapy use were an average of 5 pounds stronger than females who had reported never taking hormone replacement therapy. And really importantly, we see that this difference is increasing with age, where by the time women are in their 80s, we're seeing almost a 13% difference in strength between the two groups. Now, interestingly, though, we are also seeing that hormone replacement therapy use is at almost an all-time low at the moment. So usually using the same nationally representative data, we looked at how females reported hormone replacement therapy use, and we've shown that there's been an 80% decline in the last 20 years of this type of therapy. And in the most recent sample, less than 25% of females had reported ever taking hormone replacement therapy. So even though we're seeing that this can offset some of the performance declines that females experience later in life, many females are not taking hormone replacement therapy, and part of it is because there's been some really poor research done in this area. So we need to really continue to study women and study women in menopause as well. So keep studying women. I'll be at poster 17 if you want to talk about that.
Hello, I'm Dr. Roy Collins. I'm a sports psychiatrist with our athlete mental health team here at Stanford. The landscape of college athletics is changing really rapidly with conference realignment. And now that we're in the ACC, we've become a little bit of a test case for a problem that I think is going to continue to plague college athletes, which is onerous travel across multiple time zones. And the burden of said travel impacted a case that I want to present today of a student athlete whose mission really touched mine, which is supporting the mental health of our athletes. I present the case of a female college student athlete who presented with severe depression and insomnia, whose symptoms included very intense and severe suicidal ideation, pervasive low mood, disruptions in her sleep, poor concentration, poor energy, and the travel across those time zones significantly impacted her circadian rhythm and cycle. My colleague, Dr. Sam Hayward, and I came together to create a comprehensive care plan for her that combined medication, psychotherapy, and a total restructuring of her sleep care. Medications, I started the medication Wellbutrin, which is fairly activating, which I thought might be helpful, and also had a favorable cognitive side effect profile for her. Her psychotherapy included some motivational interviewing, and processing, but most notably included dialectical behavior therapy, or DBT, where we were able to both identify and manage a very central key stressor for her, which was isolation from her supports while she was away training and competing. Regarding her sleep, we very gradually increased her total sleep time and then very intentionally aligned her wake time to the local competition time of that day. Really happy to report that she responded very well to our integrative plan. So at the end, she, over the course of about 8 months or so, experienced a significant decrease in both the frequency and intensity of her suicidal ideation, total resolution of those severe depressive symptoms, and actually restructuring of her sleep plan to include 7.5 to 8 hours of sleep at a time. I want to present this case because I think it really exemplifies, with the nuances in this complicated landscape, a integrative and collaborative care model where we are very athlete-centered and very sort of flexible and creative with our care. As we continue to see the now professionalization of the college athlete landscape, we need to kind of come together and be more collaborative and creative in our care. Thank you.
Hi, everyone. My name is Katie Clayton, and I'm a postdoctoral fellow with the Tsai Human Performance Science here at Stanford. I work in the psychology department in a lab called the Mind and Body Lab. And in my lab, we study a lot about how our beliefs and mindsets influence our physiology, our health, and our well-being. So to give you a couple examples of what that looks like in practice, we study how things like stress or the food that we eat or the exercise that we do is the effects of those are shaped by our beliefs. And the motivation for this project was understanding in a much more broader sense how our beliefs about our bodies can potentially influence our health and well-being. Some examples of that would be, do you hold the belief that your body is capable or incapable? Do you think your body is an ally or an enemy? Do you think your body is you? Is it enough? Etc. And so to understand what all of these beliefs were, we conducted a large-scale mapping effort, which involved sourcing beliefs from a variety of different data sources. We conducted a big systematic review of over 3,000 studies related to different ideas and beliefs about the body. We coded over 20,000 tweets. We looked at hundreds of different texts, medical memoirs, historical texts, etc. We conducted qualitative interviews with doctors, with athletes, with people who've experienced bodily trauma or paralysis, lots of different people in that. And then we conducted a lot of large surveys, among other inputs. And that led us to develop an inventory of over 250 survey items that correspond to 30 unique body beliefs. And what's really exciting about body beliefs research is that now we can apply this to really interesting cases. And in my postdoc, I do that in the female athlete context. So right now we're developing a study that has to do with tracking body beliefs in pregnant and postpartum athletes. There's not a lot of research out there on beliefs to begin with. And there's also not a lot of research on pregnancy or postpartum, especially in the athlete context. And we're interested in how our beliefs can shape both return to sport protocols as well as trajectories, as well as even biological aging in pregnancy, which is sort of a new area of research. We see this advancement of biological aging in pregnancy that then seems to revert in some athletes in the postpartum period and some pregnant women in general. And so we're developing a longitudinal design that will track both body beliefs, what are the changes in those body beliefs, and core training and well-being outcomes, along with different postpartum training behaviors and biological aging. I'm excited to talk more about either aspects of this project, the mapping effort or the pregnancy study, and I'll be over there at poster number 5 for anyone who's interested.